How's everybody doing today? I hope everybody has a lot of energy on Monday to learn a lot and to start the week with energy. Today, we are going to investigate the experiment number 7 in Labflow, which is chemicals in everyday life. One important aspect of chemistry is to be able to identify substances. If we can identify quickly a substance that a child has eaten, we might be able to save a life. So we identify substances using instruments or chemical reactions, or both. In this experiment, we are going to identify substances using chemical reactions, and the substances are substances that we find in everyday life. In general, to identify a substance, we need two chemical reactions. Any chemical reaction that is to test a substance or is to identify a substance, we call it a test. But we need two chemical reactions. The first test, when we are trying to identify an unknown, the first test is going to give us a clue of what substance we have. And the second test is called confirmatory test. It's going to identify, finishing identifying the substance. So the objective of today's experiment is to identify substances that we encounter in everyday life, and we don't use the chemical names, we use the trade names. For example, we say table salt, that is sodium chloride. We are going to identify table salt, or we say smelling salts. Smelling salts contain ammonium carbonate. We are going to test bleach, and that is chlorine, or magnesium sulfate, that is Epsom salts. And the second objective of today's experiment is to identify an unknown. Luckily, you will have 4 possible anions. So your unknown will only have one, and you will have to say if it's carbonate, if it's sulfate, if it's iodide, or if it's chloride, based on all the other reactions that you did at the beginning. So if, as I always do every week, I will share the page of the experiment, and I will give you a quick overview of the experiment, and we'll do some practice practice problems, just a learning check, and towards the end we will go over the report. So let's start by sharing the page of the experiment. So the objective is here, as we just mentioned, observe some reactions of common substances found in everyday life around the home. These are the chemicals. The introduction, we talked about qualitative analysis. What is qualitative analysis? Is the identification of unknown substances. So here is talking about what is a test. We we said that what is a test is any reaction that can identify an unknown. So one thing, all this experiment is about qualitative analysis. We are only interested in the identification of different substances or ions. We are not interested today in the concentration, just qualitative analysis. So here in the introduction, it's talking about qualitative analysis, and it's talking about that what we just discussed, that we need in general two tests. We need the first one that is going to give us a clue, the first test, and the second test is the confirmatory test. For example, if we are testing chlorides, okay, the first test will be adding silver nitrate, and we mix the two solutions that are clear solutions, and we obtain a precipitate. But because there are many ions that can give us a white precipitate, we need a second test. We need to confirm. And for chloride, we add ammonium hydroxide. If we are testing chloride, we add ammonium hydroxide, and we observe that the white precipitate dissolves, and the other white precipitate will not. So that will tell us, yes, we have chloride. This is what it's talking about. And then it starts here providing all the reactions. So when you get to the report part, and you will need to write the whole chemical reaction, just look at this, come and read it again, that they are giving you all the chemical reactions and the balance equation. But be careful here. When it says OH, there is a mistake. By now you already know. OH is OH minus, right? The hydroxide ion is OH minus. And here is written with a plus, which is wrong. And then ammonia, it says AQ, is going to be a gas that we are going to test. So it has a little mistakes, but not too bad. So the first reaction, we are going to test ammonia. This is ammonia. So here they are presenting which reactions are you going to do in the lab in order to identify ammonia. Because we are not doing it, this is a virtual lab, all the data will be given to you in the first page. So in red, you will see all the answers that you were supposed to obtain. So here they are showing how we are going to test. One way of testing ammonia, we have basically, we are going to test ammonium salt. So that's why here is H4. So we are going to have a salt that is ammonium chloride, for example. And you are going to see that if you add ammonium chloride, if you add sodium hydroxide, you are going to smell there are two ways of detecting the ammonia gas. This is a gas. One way is by smelling the famous or the common ammonia odor. And the other way is because this is a gas. Do you know that what is a litmus paper, right? It's a paper that if you have an acid, you use a blue litmus paper and it turns red. With acids, the paper turns red. But with bases, the paper turns blue. You will see that more in Chem 2, more about acids and bases. But for now, you will know that if you have ammonia, it will turn the red litmus paper, it will turn blue. So these are two ways of, they are showing here, of detecting ammonia. Most ammonium salts, is saying here, are stable. So let's say you have ammonium chloride. Ammonium chloride is stable. So if you put on top of the test tube, you placed a litmus paper, there won't be a change because it's stable. Stable means it won't react, it won't form a new product. But if you add sodium hydroxide, you are adding a base, then yes, you are going to obtain the ammonia gas, which is this reaction. But there are other salts, like they are showing here, that they are not that stable. You don't need to add sodium hydroxide. Basically, you will test the formation of ammonia just by placing the litmus paper on top of the test tube. Any questions so far? How we are going to test ammonia? Okay, so the smelling salts contain ammonium carbonate. Ammonium carbonate, we don't need to add sodium hydroxide. It's unstable and will produce the ammonia odor. And the smelling salts, it says here, contain ammonium carbonate with some ammonium hydroxide. Okay, let's see how we are going to test carbonate. So you will need to kind of review a little bit all these reactions because you are going to need to write those reactions, and then in the quiz, you will need to refresh how are you going to test for these ions. So ammonia, carbonate, here they are giving you a quick overview. Any substance that contain carbonate, this ion, here they are telling us that react with acids to liberate carbon dioxide. Carbon dioxide, you know, you will see bubbles, has no color and no odor. When I say I add an acid, you are in Chem 1, so I'm not sure if you are familiar, you are adding a source of protons. The cation H plus is ion. So if you have this substance, this is bicarbonate. Bicarbonate, we use it for what? Whoever bakes uses baking soda. So this bicarbonate is baking soda. when it reacts with the acid, let's say the lemon juice that we have in cake, it produces this CO2 gas to make it more spongy, the cake. So if we add an acid, it reacts with acid to liberate carbon dioxide. So if we see bubbles, you will know, oh, the first test, if you add an acid and you see bubbles, you say, oh, I have, it's giving me a clue that I might have a substance with carbonate or bicarbonate. And then you need to do the second, a confirmatory test. And one confirmatory test is making producing the reaction with barium hydroxide. So the confirmatory test of carbon dioxide is this reaction that is right here. It produces a solid of barium carbonate and water. Basically, this is insoluble white precipitate that confirms the presence of carbonate. So you will basically need to learn what happens with carbonate. The first reaction that produces bubbles of CO2, and the confirmatory test is the reaction with barium hydroxide. So when you need to write that in the report, just come here and look at the reaction. What else are we going to test? Chloride. They're going to test chloride. The chloride salts also react with acid, with sulfuric acid. But instead of liberating the other gas that has no odor, here the chloride reacts with sulfuric acid to produce also a gas, hydrochloric acid, but the odor is a sharp, strong taste. They call it pungent and colorless gas that if you put a moist blue litmus paper, it will turn red. I said at the beginning that the litmus paper with acids always turn red. So that's a way of saying, yes, I'm having an acid here, which is hydrochloric acid. And we can have any salt. When we add sulfuric acid, what's important is that we have the chloride. So we can have any salt as long as we have chloride. It can be table salt, which is sodium chloride, can be potassium chloride. As long as we have this ion chloride and we add sulfuric acid, we are going to obtain that strong gas of hydrochloric acid. And then once we have that clue, the confirmatory test of chloride is the addition of silver nitrate. What is happening here? A solid, a precipitate of silver chloride is formed. Any questions so far? How are we going to test these ions? Okay, the next ion that you will need to learn, there are a bunch of reactions here, is how to test for sulfate. Basically, if you add sulfate, if you add sulfuric acid, you're not going to observe much. So what is the confirmatory test that, so you add, let's say, sulfuric acid, nothing happens. I said, oh, maybe I have sulfate. And then you want to do a confirmatory test. And the confirmatory test for sulfate is addition of barium chloride and forms this precipitate the solid of barium sulfate. So that will be our confirmatory test. And then what else are we testing? So many things. We are testing iodine, iodide. Here. There are many reactions for iodine. The first reaction that is describing here is the reaction with bleach. Bleach, when we buy bleach, usually is solution that has 5% of hypochlorite. But the hypochlorite, which is this substance, behaves as if we have the gas Cl2. This is a gas, it's a toxic gas. It's a pale yellow gas that has some odor and is solid in water and is toxic. But don't confuse this Cl2 gas with Cl minus. This one is a chloride that is in a solution, is combined like we just seen. This is chloride. But this one is the chlorine. So the bleach behaves as it as it contains only chlorine. So we are going to react the bleach in order to identify. We are trying to identify iodide, and bleach is one reaction that we can perform. So this is the reaction that is described here. The bleach reacts with the iodide to form iodine and chloride. So when we perform this reaction, the iodine gives a reddish, so we are going to observe like a brown color in the water because of this iodine. If we mix a salt of iodide with bleach, we are going to observe that brown in the water if we have the test tube. But what happened? Iodine is non-polar. So if we add, it's going to be more soluble in the mineral oil. I hope you understand this because you are going to need that later. So when you are making this reaction, it produces iodine. Iodine is going to be a little, you're going to observe a brown reddish color in the water. But then, in order to make sure that this is what you have, you are going to add mineral oil. And this iodine will go to the mineral oil because it's not polar and it's more soluble in a mineral oil than in water. And it's going to give you a violet color in the mineral oil. So this is one way of detecting the iodide salts. There is another way that we are going to perform that is here. It says solid iodide salts react with concentrated sulfuric acid. So when we do that reaction, immediately we are going to see a dark brown, and this is another reaction to test iodide. So basically what is happened, we are going to observe some purple of the, again, of iodine, and we are going to smell a gas. We call it rotten eggs, has a bad odor, which is the formation of this. You don't need to know the exact reaction, but yes, you need to know what happens when you add sulfuric acid to a salt, a solid iodide salt. So this is the second reaction that they are describing here. And the last reaction that they are giving us to learn is the reaction with silver nitrate. And this is easy to remember because it forms a pale, this is a solid, and the color is like a pale yellow precipitate. So if we see that, that can be a confirmatory test for iodide ion, because we are going to, if we add silver nitrate, we are going to obtain like a pale yellow precipitate. Any questions so far? Let's look at what else they want us to see. They are giving us here a table summarizing, and you will need this table as well. So basically, what are they saying in this table? Here are the four anions that you will have to identify. In your unknown, in the report, you will have one of these four, either carbonate, chloride, sulfate, or iodide. And then you will add first sulfuric acid. And you will see, you will observe, if it's carbonate, you are going to observe, as we just seen, this is just a summary, the CO2. If it's chloride, that gas that we mentioned that has a strong odor, hydrochloric acid. If it's sulfate, no observable reaction. And if you add sulfuric acid to iodide, you are going to observe a violet or red-brown vapors of iodine formed. And then this is the list of all the confirmatory tests. Once you suspect, based on the first reaction with sulfuric acid, you can perform the confirmatory test. This is a good table to summarize that. Then we will go over this. You will have to read everything. And here is just the description of, if you are in the lab, this is written as, if you are in the lab, how are you going to perform? But don't miss it. I would read it in case in the report there are questions that you might need to go back here and read the procedure as well. How are you doing to test ammonia? How are you testing baking soda? How are you testing table salt? How are you testing Epsom salts? And how are you testing bleach? And then the F is the unknown. So there are a bunch of reactions that you need to get familiar with, but it's not that bad. Any questions so far in this quick overview of the experiment? So then we will go to look at some questions here that I prepared just to make sure we are in the right track before we go and look at the report. So based on what we saw, let's look at the first question. It says, what test should you perform first to your unknown? So the best way of doing this is, let's so you know that your unknown is going to be one of these four. That is the good part. It's just one of these four. You will have to answer, I have carbonate, chloride, or sulfate, or iodide. Either one of each. Only one. But it says what test. If you are in doubt, what you do, let's share again the other page of the experiment, just to give you an idea of how you are going to do this. And then we look at here. That's why I said, even though you are not doing it, you will need to be familiar with the procedure. This is the last page. So if you read here the part of the unknown, you will have to come here if they ask you that question. And here is basically written. It says your solid unknown contain only one of the following ions: carbonate, chloride, sulfate, or iodide. And the table 3 summarizes the behavior of these ions towards sulfuric acid. And here is basically described. It says, place a small amount of your unknown in a small dry test tube and add a drop of concentrated sulfuric acid and record your observation and the formula for the unknown. So the question would say, let's go back to the question and you will tell me what are you going to answer. So you can unmute yourself. What would be the answer to this question? What test should you perform first? We just read. Any ideas? Somebody can text or send a message. Yes, thank you, Douglas. I'm so happy. Exactly. Very good. Somebody is paying attention. I'm happy about that. That's what you are going to answer. You are going to say, we place a small amount of the unknown in a small dry test tube, exactly as it says, and we add a drop of concentrated sulfuric acid. And then, according to table 3 that is in there, the reaction of solid salts with sulfuric acid will give us a clue of which one of the 4 ions we have. So when we read that table, if we have, let's say, carbonate, and we add sulfuric acid, we are going to see bubbles of CO2. If you look at the table and you have a chloride, you're going to see a gas that has a strong smell. When you add sulfuric acid, if you have sulfate and you add sulfuric acid, no observable reaction. And if you have iodine and you add sulfuric acid, you're going to see kind of violet or red vapors of iodine. Very good. Let's look at the question number 2. How do we confirm the identity of the unknowns? That we also look at the part that was written in the table. And you remember, let's say we got bubbles. So if we suspect that we have carbonate, well, you know that the reaction with barium hydroxide is going to confirm the presence of carbonate, because you know that a white precipitate of barium carbonate is observed when first we add some drops of hydrochloric acid, and then we will hold the drop and read the procedure as you are doing, and you will see a white precipitate of barium carbonate. And the reaction is written there. Is basically, once you add to the carbonate, you add acid, you obtain the gas, right? And then we said that the confirmatory test is the reaction with barium chloride. So what is forming? That is the white precipitate that we are going to observe. Barium carbonate plus water. All these reactions are given in the background, so you don't have to worry. They are all given. So this would be the confirmatory test for if we suspect that we have carbonate. What would be the confirmatory test if we think we have chloride? That is easy. We add silver nitrate, and we see a white insoluble precipitate of silver chloride. So basically, the chloride, you add a solution of silver nitrate, and you see a solid of silver chloride, and you confirm the presence of sulfate. What happens if you suspect that you have sulfate? You add sulfuric acid and there is no reaction. You said, I might have sulfate. And then the confirmatory test that is described is the reaction with barium chloride. Also produces, you mix the two solutions and forms a solid of barium sulfate. What is the confirmatory test for iodine? If we suspect we have iodine. You can read it, you have all in your write-up, but there, either one. If you add silver nitrate, you are going to have, instead of having this solid that is white, you are going to have also a solid, but it's a pale yellow precipitate, has a different color. So you identify the iodine. That is one way. It can be another option is when we add bleach. Remember what we said. When we add bleach, we have a reaction. The chlorine, the bleach is exactly as if it has chlorine dissolved. So when the chlorine, we saw it before, reacts with iodine, it produces the iodine This is another confirmatory test because it gives that brown color to the water, and then we add mineral oil. It actually is a nice test to do because it's more soluble in the mineral oil. It will give you kind of a violet color. So that's another confirmatory test to iodine. And then let's see, what does it say here? How do we test ammonium salts in this experiment? Yes, thank you, Douglas. Exactly. Very good. Exactly. We test the ammonium salt by adding sodium hydroxide. And then we notice that common odor of the ammonia, or by using also the red litmus paper. Because it's a gas, we can put the paper on top of the test tube and see if it turns the color. It will turn the red litmus paper, it will turn blue. And then, okay, so this is what we how we tested. Most salts we said are stable. So if we have, this is the reaction, right? We have ammonium. And as Douglas said, reacts with sodium hydroxide. It's going to make ammonia gas, and we are going to smell glass water. Most ammonium salts are stable. So if we have this salt, unless we add sodium hydroxide, we won't smell the ammonia. But some others, as we said, ammonium carbonate, we don't even need to add sodium hydroxide. We'll smell because they are unstable. So this is just a quick overview and view, just to make it easy when the time comes for you to do the quiz and the report. Any questions so far before we go to check on the experiment page? So when the time comes to complete your experiment, all this that is written in red is going to be given to you. So basically, the effect of household ammonia on dry litmus. If the litmus paper is dry, there is no change. It's going to stay red. So you can read that. When it's moist, then yes, then produces that changes to blue. This is what we were just saying. So read that because you will need to know what are the effects of this reaction. This is a nice summary. Unfortunately, you cannot observe what we just went through. These are the answers of what you are going to observe. And then the second page, you will have an unknown. So it will ask, based on your observation in part A, with the effect of fertilizer plus sodium hydroxide on litmus, does fertilizer contain ammonia? So what are you going to do? You have to go again back to the first part. and look at ammonia, and you will see, okay, what happens when ammonia reacts with sodium hydroxide? It says changes to blue. We just seen the reaction, the paper changes to blue. And then you look at the fertilizer and you say, okay, is it different or is it the same? It's the same. So are we assuming that we have, that the fertilizer contains, we can say yes, because we come here and we look that it has the same effect of an ammonium salt. So it might have ammonium. So this is the way that you are going to answer. And then what happens with the smelling? Let's look at that. They will ask you here, effect of smelling salts. And it's they will ask you, they contain ammonia. Okay, you will look. Again, the same effect. So it seems that yes, they do. You will see also the formula. So this should be very, very easy. And then it will be another question about, let me see, the chalk. So basically you will compare the reaction that you obtain with what they are asking you. So basically this is just observing. Here they will ask you to complete the chemical equations. You have all that. It's given to you. And then they will ask you, why should you have used distilled or deionized water instead of water? That is obvious. And you will have that also in the videos that you are going to watch. What happened if you are testing chlorides and you use a source of water that already has chloride, right? It's not going to work. And here in the last part, it says the tap water contains chloride ion. Well, you will see based on the observations in red. So everything is given, and then the last part is the unknowns, and it says you observe the following when adding sulfuric acid. So you will use in that part the table 3, depending on which reaction, what did you observe. It says, okay, in this case, it says no observable reaction. So you have a clue, and then you look, okay, what is the confirmatory test for that? And then you'll answer. It seems that this is pretty simple. There are many reactions to learn, but it's straightforward. That's how I'm seeing it. Do you have any questions so far? Okay, so I will conclude this workshop here. I will stop the recording and then I will stay in case you have questions. And thank you everybody for coming today.